educational me, Department of Chemistry, KRM DAV College, Nakoda. Going to present the topic of spectroscopy incorporated in BSc final year semester. What is, first of all, starting with a brief introduction of spectroscopy. What is spectroscopy? Spectroscopy is the interaction of radiation with matter. Matter can be any chemical compound or an organic compound. Basically, spectroscopy is used to elucidate the structure of the chemical compound. The technique used is, we use a source of radiation which is electromagnetic radiation. What is electromagnetic radiation? Electromagnetic radiation are the radiations which have electric field and magnetic field perpendicular to each other as well as to the direction of propagation. When it strikes our sample of chemical compound, if we use electromagnetic radiation of intensity I0, when it passes to the sample, a part of the radiation is absorbed and rest of the radiation is transmitted. Let the transmitted radiation has the intensity IT. Somewhere books use simple I symbol, that doesn't matter. When it absorbs radiation, we can record absorbed radiation as well as the transmitted radiation. When our detector used to detect the absorbed radiation or either transmitted radiation depending upon the instrument used. That detector used to convert this radiation coming out of the sample into the electrical signal. That electrical signal is converted into the graph in our computer. Like computer records the plot of absorbance versus wavelength in UV spectroscopy. That is we have spectra like this. We have a peak in the spectrum. Electromagnetic radiation actually carries energy. That energy gets transferred to the electron present in the molecule. Initially, electrons are present in the ground state. Ground state is the lowest energy state. When we have not provided any energy, electron remains in the ground state. But when we provide energy in the form of quantas according to Planck's quantum theory, that electron gains energy and get excited to higher energy level. When electron is present in the lowest energy state, that is called ground state. When electron gets excited to the higher energy state, that is called excited state. When we record the energy in going from electron energy level E1 to E2, that is called, we are recording absorption. The spectra corresponding to absorption is called absorption spectroscopy. excited state is always an unstable state. Means electron will tries to come to the lower energy state. When electron tries to come to the lower energy state, it means it will lose energy in going from E2 to E1. That will be emitted in the form of light, and if we record this energy, the emitted energy in the instrument, and have a graph, that is called initial spectroscopy. It means spectroscopy is broadly divided into two kinds of spectroscopy: absorption spectroscopy and emission spectroscopy. Here we note the absorbed energy, here we note the emitted energy, as I have already explained with the diagram. But absorption spectroscopy is easy to operate, as absorption energy, however, both spectroscopy gives the similar information about the difference between the lower energy level and the higher energy level. The difference between means final energy level and the initial energy level. If we are noting down the absorbed energy, then it is E2 minus E1. If we are noting emission, then it is E1 minus E2. Absorption, as I have said, that it is easy to operate the absorption spectroscopy. Absorption of radiation may bring increase in rotational or vibrational energy of the atom and electronic excitation. Or it may increase vibrational and rotational energy of the molecule. To excite the vibrational and rotational energy level, we need IR radiations. IR radiations are infrared radiations. However, electronic excitations can be done by using UV radiations. UV radiations means ultraviolet. Both radiations are of different wavelength. We will discuss it later.